my name is Joel Dunay, and I would like to show you my official unofficial solution for the network state exam topics. And the first one, and now the 10th topic, which is about the network layer, is coming. The main functions and the services of the network layer of the OSI and the TCP/IP based systems. So of course here you can draw up the OSI model. We are talking about the third layer from the bottom. So network layer is the third one. Here we are talking about routers. So the important stuff about them is they are forwarding messages, they are forwarding packets from one network to another or just simply to the destination, and they are calculating the best path by using their routing tables. Also, they are doing the encapsulation, and the encapsulation, of course, it receives the data from the transport layer and encapsulates it, and when it receives a frame from the data link layer, then de-encapsulates it. Yeah. So basically that's the main functions. The structures of the PDU and the main field is really easy. We have the data, and we have the network header on it, and we have at the beginning, so we have the data, we have the transport header, and at the beginning we have the network header. So in the network header, the most important stuff here, that we have the source and destination IP address, and these IP addresses will remain unchangeable during transmission because they are identifying the source and the destination, and based on this the device will determine to where the packet should be forwarded, and the destination will see that whether it received a good packet or not. So as I said, these are the main fields. Also, there are fields that are mutable. That means they are changing during the transmission, like the time to live, which by, if I remember well, 15. So if the time to live will reach 0, then the packet will be discarded. Say for example, if a loop occurs, then it can be discarded. If I remember well, it has a version in the frame, in the network frame, a version field, and maybe there is a differentiated service field where, for example, the priorities can be set for packets. Of course, we are talking about the network layer. So as I said, we have the source destination IP. So IP, we are using the internet protocol. IP is connectionless. That means before the transmission, a logical path is not being created and maintained and terminated at the end. Here we are sending a packet, and we really don't care whether the packet will be received or not. So it's connectionless, it's best effort, which means it's unreliable. That I've just said that we are sending something and we don't guarantee that it will be received, and we don't know whether the receiver received it. But it uses low overhead, I believe, because of these stuffs previously. If it would be connection oriented, it would have a higher overhead, for example. So the services and functions of the network layer in case of IPv6 and IPv4 and IPv6 protocols, this is really long. So I'm going to tell here the IPv4 because there is a topic about IPv6, so I'm going to tell you there all the stuffs that you have to mention here about IPv6. So the services is quite simple. We have public and private addresses, and imagine that there is a router that connects the inside network with the outside network. What happens? You have a private network in the inside, and you would like to send a traffic to the outside network, and by default the traffic will be discarded on the router because it will realize that it has a private address and it will not forward it to the public, to the internet, to the untrusted network. So you can handle this by creating network address translation, which simply does what its name indicates, will translate your private IP address to a public one. So in this case, you can send traffic to the internet as well, and of course that is inspected, that can be received because it is inspected. The other important is of course the DHCP. I don't know how deeply you have to talk here about it. I'm not going to talk about deeply here because there is a topic about DHCP, so you will hear everything there and then you can tell here everything. So it does DHCP, dynamic IP address allocation, and I believe that's all important in case of IPv4. IPv6, of course, there we don't need network address translation because there the address space is much more, therefore there we don't need it, but there the DHCP version 6 is important. The PDU transmission mechanism between endpoints in the third layer. I've talked about this previously, but how does it work? Of course, okay, so let's say that from host A we send a message to a packet to host B. So how's it going to happen? We have two cases. The case A, in which it will be immediately sent to the destination, so it will be received by host B, and we have the second case when we are going to send it, but it will not be received immediately, but it has been received first a network device, for example a router, another router, and from that router it will be received by the destination. So if we consider that the second case, when it will first pass to another router, the other router will de-encapsulate up onto the network layer, checks the IP address, the destination IP address, checks its routing table, and will re-encapsulate the packet and will forward it to the destination. And of course, exactly the same does if we send immediately to the destination, but then we will not forward it to elsewhere. The device host B will check the destination IP. It will realize that, hey, this is my IP address, so I'm going to de-encapsulate the layers above it as well and check the data. The purpose and content of the IP header fields, control and error messages. So as I said, I talked about the header fields, but as I said, it's connectionless, for example, so therefore there is no guarantee that the data has been received. But even though with the help of the ICMP protocol we can have some error messages in case of the IP, because the ICMP can help to check or verified destination, and I believe there are three more times, but I always say this, or whether there is a path to the destination, and that's all. So simply these ICMPs are helping. Of course, we can do the ping and echo is the reply if the destination is available, and for example we can check whether we can get to a destination or not. So these can help to give errors to us. The fields of the header that change and remain unchanged during transmission. As I said, the source and destination IP will not change during the transmission, but for example the time to live will change, and I don't know which else are changing during the transmission. The encapsulation and de-encapsulation process during the operation of third layer process, I've told about this, and that's it. Again, if I said something wrong, then I don't care. And don't forget to subscribe to my channel.